Welcome to the deep dive. Today we're diving into your research on Einstein's theory of relativity,
Mm-hmm.
and we've got some really fascinating material to work with here.
Yeah,
We have excerpts from a book by Professor Lorentz,
right.
who's a prominent physicist and a contemporary of Einstein.
Yes, he was really a giant in the field in his own right.
So it's like getting a front row seat to this like revolution in scientific thought.
Absolutely. A unique perspective on this world-changing theory.
Yeah, for sure.
Yeah.
So before we get into Lorentz and his perspective, though, I think it would be helpful to kind of set the stage. What was the state of physics, especially regarding gravity, before Einstein came along?
Well, imagine a world where a Newton's law of gravitation is like the gold standard,
Okay.
right? For centuries, it explained how objects attract each other, but the underlying why remained this like big mystery.
So it's kind of like having a map, but not really knowing like how to use a compass.
Exactly. You've got the how, but the why is completely unclear. And while other areas of physics were kind of like advancing really rapidly, like electromagnetism,
Hmm.
gravity remained this puzzle that no one could quite solve.
Okay, so then Einstein enters the scene.
Right.
What was so groundbreaking about his theory? What was his like big breakthrough?
His big breakthrough was the idea that gravity affects not just matter, but also light itself.
Light.
Yeah, light.
Wow, okay.
Which is a wild idea when you think about it.
That's a huge shift. How did that change our understanding of gravity?
Well, before Einstein, physicists believed in this thing called the ether,
Okay.
which was this invisible medium that they thought light traveled through.
Okay, so they thought there had to be something that light was traveling through. It couldn't just be traveling through nothing.
Right, exactly. They needed something to fill in that gap.
Okay.
And they thought if the Earth is moving through this ether, then we should experience something called ether wind.
Ether wind, so like the wind you feel when you stick your hand out of a moving car window?
Yes, precisely. But here's the thing. Every experiment they did to try to detect this ether wind failed.
Interesting.
So Einstein comes along and he's like, well, what if we just get rid of the ether altogether?
So he just scrapped the whole idea.
He did. And that was his genius.
Wow.
He said that the laws of physics should be the same for everyone, regardless of their motion.
So he basically like tossed the ether idea out the window and in the process challenged centuries of established physics.
He did. It was a bold move.
Wow.
And this is where his genius really comes in because he needed a completely new way of thinking about the universe.
Okay, so if we're not thinking about the universe as having this ether that everything is moving through, then how are we describing the position and movement of like planets and stars and everything else?
Well, think about a grid system,
Okay.
like the latitude and longitude lines on a map,
Okay, I got you.
but extending infinitely in all directions.
Okay.
Before Einstein, scientists used these grids with their fixed coordinates to describe the universe.
So like a universal game board
Yeah, exactly, like a fixed reference frame.
with like fixed squares.
Exactly.
Okay.
But remember, Einstein just removed the game board itself, the ether?
Okay, so now what?
So now he needs a new way to describe the positions and motion of all these celestial bodies without this fixed reference point.
Okay, so how did he do that?
And he found a way.
Okay.
He realized you could use any system of coordinates as long as your description of gravity remained consistent within that system.
So instead of being bound to that fixed grid, he introduced the idea that we could use a flexible, adaptable framework.
Yes, exactly.
Right.
Think of it like using GPS to pinpoint a location on Earth.
Okay.
GPS satellites, they don't rely on this rigid grid on the ground. Instead, they use a system of coordinates based on their position in space relative to each other and the Earth.
That's a great analogy.
Yeah,
So Einstein essentially gave us a more flexible and dynamic way to describe the universe.
exactly.
But I imagine this new system came with its own set of challenges, right?
You're absolutely right.
Like, how do you even begin to work with that?
It was elegant, but it was also far more complex mathematically.
Okay.
Instead of using one fixed value to describe gravity, Einstein's theory employed 10 values
10.
that vary depending on the location in space-time.
Wow. From 1 to 10. That's a pretty significant leap in complexity.
It was, but it was also a leap towards a more accurate representation of reality.
Okay.
And here's the fascinating part.
Okay.
Einstein's theory didn't completely invalidate Newton's work.
Okay.
It showed that Newton's law of gravitation was a simplified version, applicable in most everyday scenarios, but incomplete when dealing with like extreme scales, like
Okay.
really massive objects or near light speed travel.
So it's less about like right or wrong and more about like expanding our understanding, like refining the tools that we use to kind of comprehend the universe.
Exactly.
Okay.
And Einstein wasn't just theorizing. His work provided explanations for phenomena that had puzzled scientists for a long time,
Like what?
like the mystery of Mercury's orbit.
Mercury, the planet closest to the sun.
That's the one.
What was so weird about its orbit?
Well, astronomers had observed that its orbit showed this slight wobble, a deviation that Newton's laws couldn't quite explain.
Interesting.
It was this tiny discrepancy that had stumped the scientific community.
So Einstein's theory, like, accounted for this.
It did.
Wow.
His equations, which considered the warping of spacetime by the sun's gravity, perfectly predicted Mercury's orbital wobble.
Wow. So that was a pretty big win for him.
It was a major victory for his theory.
Okay.
But the truly groundbreaking validation came a few years later during the solar eclipse of 1919.
Oh, yeah, I've heard about this. This is the whole starlight bending thing, right?
Yes. Einstein predicted that gravity could bend the path of light.
Okay.
He argued that the sun's massive gravity warps the space-time around it, causing light passing close by to bend slightly.
Wait, so you're telling me light doesn't always travel in a straight line?
That's exactly what I'm telling you.
That's mind-blowing. How could you even observe that?
It's tricky. But a total solar eclipse offers a perfect opportunity.
Okay.
When the moon completely blocks the sun's light, you can observe stars that appear close to the sun's edge.
Because the sun's light isn't washing them out.
Exactly.
Okay.
During the 1919 eclipse, astronomers seized this opportunity.
Right.
They compared photographs of stars taken during the eclipse with photographs of the same stars when the sun was in a different part of the sky.
That happened.
They found that the stars' positions appeared to have shifted slightly,
Okay.
and not just by any random amount. The shift aligned precisely with the amount predicted by Einstein's theory.
Are you serious?
I am. That's exactly what they found.
That's incredible talk about validation of a theory.
It was a defining moment in the history of science.
Wow.
Here we had a theory, elegant yet complex, that not only explained existing mysteries but also made bold predictions that were later confirmed through observation.
It must have just sent ripples through the scientific community.
It did. It was huge.
But I have to admit, all this talk about space-time curvature and gravitational lensing makes it sound incredibly complex.
Yeah, it definitely can be.
Did Einstein ever try to make his theories more accessible to, like, the average person?
He did.
Really?
Professor Lorentz in his book addresses this very issue.
Okay.
He counters this perception that Einstein's theory is too complicated for the layperson to grasp.
Okay.
In fact, he highlights Einstein's own book about the special and the general theory of relativity in plain terms, as evidence that the core concepts can be understood without diving deep into the complex mathematics.
So Einstein himself recognized the importance of making his work accessible to a wider audience.
Absolutely.
That's really cool.
And that's where something like Project Gutenberg becomes incredibly valuable.
That's so cool that he, like, took the time to explain these super complex ideas in a way that, like, more people could wrap their heads around it.
It really speaks to his belief in the power of, sharing knowledge and making it accessible.
Yeah, for sure.
And you're right, that's where Project Gutenberg comes in.
Okay. Which, for listeners who might not be familiar, it's this digital library that provides free access to, like, thousands of books, including, as you might guess, Einstein's own explanations of relativity.
Oh, wow. So anyone can just explore these groundbreaking ideas in Einstein's own words.
Exactly.
That's incredible.
It really speaks to the democratizing power of technology, doesn't it?
It really does. It's like it removes those barriers to accessing knowledge, and it allows anyone with curiosity and an internet connection to, like, delve into these really fascinating concepts.
Exactly. You don't need a university library, just your computer.
Love it. Okay, but before we get lost in, like, the digital stacks of Project Gutenberg, let's bring it back to the heart of our discussion. Did Einstein's work, like, completely overturn centuries of Newtonian physics?
That's a really common misconception, actually.
Okay.
Professor Lorentz really emphasizes that Einstein's work didn't invalidate Newton's.
Okay.
It, like, expanded upon it.
Okay.
Newton's laws are still remarkably accurate for most everyday applications.
Because we're still using them. Oh, absolutely.
good.
They're still the foundation for things like calculating the trajectory of a spacecraft or understanding how objects move at a human scale.
Right.
It's when you start venturing into the realm of the very large, the very fast, the edges of the universe where gravity reigns supreme. That's when Einstein's theories really come into play.
So it's less about, like, replacing one set of rules and more about, like, discovering a deeper, more nuanced understanding of how those rules interact.
Mhm.
and how they kind of manifest at different scales.
Precisely. It's like zooming in and realizing there's a whole other layer of complexity you couldn't see before.
I like that.
Einstein provided a new lens through which to view the universe,
Right.
one that revealed this beautiful interconnectedness of space-time and gravity in a way that had never been imagined before.
It's like he handed us a more powerful telescope, and we were suddenly able to see farther and understand more than we ever thought possible.
The perfect analogy, and like any good tool, it opened up new questions, new avenues for exploration.
Right, because it's like the more you know, the more you realize you don't know.
Exactly.
Yeah.
It pushed the boundaries of human curiosity, and it sparked this quest to unravel the mysteries of the cosmos that still continues to this day.
It's amazing to think that even now, like decades after Einstein first presented these ideas, scientists are still exploring the implications of his work, delving deeper into this universe that he kind of helped us to understand.
And that's the beauty of science, isn't it? It's this constantly evolving journey of discovery,
Mhm.
where every answer often leads to more questions, more mysteries to unravel.
And more things to get excited about.
Exactly.
So I guess what you're saying is Einstein's legacy lies not just in the theories themselves, but in that spirit of inquiry, the relentless pursuit of knowledge that his work embodies.
I think that's a beautiful way to put it.
It's inspiring to think about, you know?
It is inspiring.
It's like a reminder that the universe is full of wonders that are just waiting to be uncovered.
Absolutely.
Who knows what groundbreaking discoveries await us just beyond the horizon, right?
Who knows what we'll find?
And maybe just as Einstein built upon the work of Newton and those who came before him, future generations will stand on the shoulders of giants like Einstein and push the boundaries of knowledge even further.
We can only hope so.
It's exciting to think about what the future holds.
It really is.
Well, on that note, I think this has been a fascinating deep dive
I agree.
into the world of Einstein's relativity.
It's been a pleasure exploring these ideas with you.
Thank you so much for joining us and sharing your expertise.
Thank you for having me.
And to all our listeners out there, keep those minds curious and never stop exploring those big questions. Until next time, this has been The Deep Dive.